All right, so last time we left off with our discussion about the control statements. Really, this is one of the most important parts of the language because this is what makes it possible to determine the sequencing in which you're executing commands. And so all the other details I showed you yesterday were important, but this is really getting to be the heart and soul of any program that you might end up writing. So we'll start with the control statements that you see here: if then, for next, do until, do while, select case, and go to. Now, realistically, it's these two that you'll be using the majority of the time. These are for more specialized cases: do until, do while. Select case is, again, something that's a little bit more specialized. It's meant for cases where you have several different choices, and they may not necessarily follow each other numerically. And then go to is like a blast from ancient history in computer science. In the early days of programming languages, go-to statements were used, and they led to what is often called disparagingly spaghetti code, which meant it was almost impossible to trace the logic with all these go-to statements floating around. But very, very, very occasionally, you might find it helpful. So it's in here too, but the chances of you needing it are pretty remote. So anyway, we'll start with if then. So then really the whole point of this statement is that the computer will do something as long as a certain condition is true. That's all it is. Okay. So for example, now look at this simple case. If x is less than 10, then y equals 100. And if. So that means if x is strictly less than 10, then y will be assigned the value of 100. Otherwise, nothing happens. It just says, oh, that's not true, therefore I stop. Now, if you notice, we start with an if statement. The VBA program will automatically provide you with this and if statement that wraps up the entire structure. Without that, it will not know when to stop. And so it'll make sure that you haven't forgotten about that little detail. So actually, hold on one second. If we look at all the examples that we had open yesterday, we might be able to find one of these. Let's see if it's still open. Yeah, here it is. All right, of all these different examples that we had open, here's one. Now, this is actually more of an example of a more complicated case because you can see here that you've got if, then. And what's happening here is that because this is a complicated problem where we've got grades, potentially up to 5 different grades, depending on somebody's scores. What this does is it extends the if-then statement to say, well, listen, instead of all or nothing, what it might do is say, well, listen, if in this case, as you can see, if the average is less than 60, then give the student an F. But if not, we have other choices. For example, if their grade is between 60 and 70, then they get a D. And if that's still not the condition that we're running across, we can try migrate to C if their grade is between 70 and 80. And it goes all the way down to A. But if you notice, these require this statement, else if. So this complicates everything quite a bit. So the original if-then statement is quite simple, but you can see it can be extended if we need it. So yeah, just very simply if, then, and if. End of story. Then, oh, all right, here we go. That was a coming attraction, I guess. Else if is for more complicated situations where it's not just yes or no, where there could be multiple possibilities that we have to think about, like what your grade is on a test. Could it be an F, a D, a C, a D, a B, or an A? So here's one that I put together. This one's a little bit simpler. This is a function that we're writing with property tags. And if you notice, I'm making sure that when somebody provides the price to this function, that it is treated as a single precision variable, which in other words, it can be dollars and cents rather than just an integer. And so here, if you notice, it says if the price is less than 200,000, then the property tax is 5,000. And again, be careful. This has to match the spelling of the function. Okay, that's how it knows that this is the information that goes back to the function. But else, Well, actually, this one doesn't even need an else if because there's only one other condition. Else property tax is 7,500. So in other words, and the else if is for even more complicated situations where there could be potentially even more possibilities. So here, because there's only the two of them, we can keep it simple and we can just have less than 200,000. We have this property tax. Otherwise, no matter what else is true, then it's going to be 7,500. And then we have if, we need an end if to follow it. And of course, the function itself needs an end function statement, both of which are supplied to us automatically by VBA. Okay. I don't know if I have any more examples like this. Okay. So then yes, then we mentioned else if. Else if is for more complicated cases. So let's go back and revisit that example of the grades because there's five possibilities instead of just two. That's why we need the else if statement so that it continues until we've exhausted all the possibilities. So if you notice here, as we get towards the end, first, if the average is below 60, then we give it the person an F, and the program actually stops at that point. And then the letter F is returned to the calling function. Now, by the way, here's an interesting example. Um, we're being told that the average that's being read into the program is a single precision variable, meaning it can have a decimal part. But if you notice, the variable that comes out of the program is a string. Now remember, string means we have letters and characters and other things. That's important when you're coming to the strings. Yeah, it's very sensitive about strings. You really have to be very careful because otherwise, if it thinks you mean that it's a number, it'll get confused, and it might end up giving you the numerical equivalent of that letter. But just to be on the safe side, we're calling it as string. So else if 60 to 70 means we get a D, else if 70 to 80, we get a C, else if 80 to 90, then we get a B. And if none of those are the case, then the only remaining possibility is that we get an A. So you notice how we ended up with else my grade equals A. Okay, we don't need an if any longer because that's the last possible case. And then of course we need end if because we started with an if. Here we have an end if, and then the function that has to be ended with end function. Okay. All right. My printer shows that exact moment to start testing itself. All right. Anyway. Oh, okay. Sign result X is single S string. Okay. So single precision variable X is coming into the function, and we're producing a string variable on the way out. If X is less than 0, then sign result. And again, make sure these are spelled exactly the same. Equals, and also when you're using a string variable, make sure that it's contained in quotes. And if you notice, the next possibility is that it's exactly 0, neither positive nor negative. So we really need three possibilities here. We need strictly less than 0, strictly greater than 0, and 0 itself because of the way it's set up. So then we have else if X equals 0, then sign result equals 0. Now, since this is the last one, it goes back to else. So we don't want another if here because it'll think something else is coming after that. So the last possibility here is going to be invoked with else. And that what it's basically saying to it is that this is the default case. If none of the others are true, this is what we'll do. Okay. And then we end it. So this other one, if you noticed, the last one was just plain else. I'm not absolutely positive this colon is necessary, but it won't hurt anything. So that way you can tell this is the default case, meaning that if none of these are true, we'll let the my grade equal A. Now, by the way, I do want to mention here that when you have a messy case like this one, there's a special structure designed for these types of situations called case, and it makes it a little bit easier to organize a situation where there's many possible values that could come out of this. So the else if structure is fine as far as it goes, but it can get very cumbersome. So when you have a very complicated situation like this, one of the other control structures might be a better choice. Okay, we'll get to that. Here's and. We haven't used this up to this point. Now remember, that's a Boolean variable. It has to be defined that way. And oh, this is the example we were just looking at. But if you notice here, there's the keyword and. Okay. So and means this is true and this is true, right? So that way it knows that if it's just one of them, that's not good enough. It has to be both. So this is the Boolean operator. It's understood by VBA what it means. You don't have to define it. In fact, it would get confused if you did. But and is one of those Boolean operators that it comes with. And so anyway, for next. Now this is another, you're probably gonna use it a lot. If you know in advance how many times you're going to need to repeat a process, this is probably the way to go. Because it's basically saying do something a fixed number of times, and I will tell you how many times that is. So here we go. So here's your function counter, and as integer, sum. Now this sum, by the way, is an internal variable. It'll only be used inside this function. It'll not appear outside of the function. It's an integer, of course. We have to implement it, or we initialize it as 0 just to make sure. If you don't do this part, you're asking for trouble, because if you assume that it starts at a 0, that isn't necessarily going to be true if you've run a similar program earlier and that word sum is still in the memory somewhere. So just to be on the safe side, just, whatever variable you need to use, you should always initialize it as 0. Okay. It's like anything else. Make sure you always make sure you locked your door, things like that. Just make sure that you're starting at 0. Now here's the loop, and it's called a for loop, or for next loop. For x equals 1 to n, sum is incremented by whatever the sum is now plus x. Then you go on to the next x. Now this will continue until we reach n, whatever that number is at the end. Whatever the sum is that was accumulated in this loop, it's going to be assigned to this variable counter, which in turn is the name of the function. So if you want to see how this works, let's copy this code into the notes and let's just follow the logic. All right, so this is the code. So imagine yourself passing in, let's say, a 5. What you're trying to find is the sum of the first 5 integers. Sorry. All right, sum equals 0. X equals 1. All right, so in other words, sum is 0. X starts at 1, and it will continue to accumulate. And then sum equals sum plus x. Great. Then it goes on to the next x. It means you're taking its current value plus the new x. And then you go on to x equals 3. So since it says sum equals sum plus x, you take the current value, add the new x. There's your 6. Then x goes on to 4. Sum equals sum plus 4, or x, and that's 10. And then for the last time, because remember n is 5, so therefore we're only going to go out to 5. X is 5. Sum equals sum plus x, which means 10 plus 5. 15. And then because we've reached the end of the loop, it stops and it assigns whatever this is to the counter. And that's the value that's returned to the function. Okay, so this is how a classic for loop works. Okay, it does something a fixed number of times. That number of times can be passed to the function. Okay, because if somebody else wants to know the sum of the first 10 integers, then they would simply say, let n equals 10. And then it would go through the same thing. Now, there's a way, if you really want to, you can ask VBA to show you all these intermediate steps, but we're not going to dive into that right now, but this is how a for loop works. Now, sometimes you may not necessarily want to go through all, let's say the loop like this, 1 through 5. What if you don't need all the values from 1 to 5? Let's say you only need every other one for some reason. What you can actually do is use this step command, which increases the loop 2 at a time. Okay, so like if I added the step 2 command to it, then the only x's that it will consider are 1, 3, and 5 instead of 1, 2, 3, 4, and 5. Okay, now what's interesting about that is that that means you can make the loop go backwards by using step -1. Now, how wild is that? 5, 4, 3, 2, 1. If there's some reason why that's more important or more useful, you can actually go backwards by specifying that the step is -1. And of course, you can have any -1. It could be -2, it could be anything. Um, Nested loops. Now, sometimes you need to have a loop within a loop, like filling in a matrix. You want to fill all the rows, then the columns. So here's an example of this. Subarray fill. Now, this is a subroutine or macro, which is important because this way it's not restricted to a single output. We got two indices, I and j, which are both integers. If you notice, we're defining a two-dimensional array, which is a matrix, 5 rows, 5 columns. As an integer, which means that the matrix will only contain integers. How do you fill it in? Well, in this case, let's just say what we're interested in is the products of I and j, which means the row times the column. So the first loop is I, that would be the row. The j is the column. So for each one, my array ij is the product of the row times the column. Then, now here's where it gets interesting. Cells.ij value. This is where it gets printed out onto your spreadsheet. So every time it stores a new value in the array or matrix, it's going to simultaneously print them on the spreadsheet. And then if you notice, you need two next statements because, to complete both loops. And so in other words, for the first row, you'll fill in all the columns. And then the next row, same thing, go across all the columns, and then you'll eventually be finished. Okay, so that's what this is illustrating here. So, and this is what it's going to look like. Of course, as you can see now, by the way, in Excel, you know that the headers the columns are labeled with letters, but Excel internally treats these as numbers. So in other words, cell 2, comma 3, which means row 2, column 3, the answer there will be 6. The letters, that's a tie back to the days. Excel was originally intended to be an accounting program. And it was really meant for, financial statements and things like that. And I guess at the time, it would seem like accountants aren't too terribly worried about matrix algebra. So they made it, what they thought was more convenient. But as far as math goes, we just have to be aware that those letters actually are stored internally to Excel as numbers. Now, now this is different because this is a loop, like a for loop, except where you don't know in advance how many times you want to run through the loop. So in other words, instead of saying for x equals 1 to 10, you might say do the following until x equals 5 or something like that. So when a certain condition is met, it stops. Like here's a good example of this. Do until, the function is called do until loop. It's going to be read an integer. We have two internal variables. My result is an integer, x is an integer. We zero out the my result. X is defined as 1. So until x equals n, whatever that number is that was passed to the function, let my result equal itself plus 2 times the existing x, and then increment the loop by x equals x plus 1. And when you're done, then you'll have your result. Um, yeah, so I mean, if you want to run through this logic, let's take a look at this. And yeah, I missed the last one. Here we go. Let's put these in here. All right. So you start with x equals 1. My result um, is going to start at 0. By the way, if you notice, this is where we're using to keep track of results. But at the end, because the function is called do until loop, at some point you have to assign a number to do until loop. So the way we do this is we let my result be a counter variable. It keeps track of information. And then when we're done adding to it, we let that be equal to do until loop, and that's what gets returned to the function. Okay, so if you left out this last step here, you would never get a result because it's looking for do until loop and it only is finding my result. It doesn't know what that means. All right. All right, so do x until x equals n. My result is the current value plus 2x, which means 2. Okay, then x is incremented. 6. So keep in mind, oh, I forgot to specify. Let's just say we chose 5 for n, which, by the way, the way this is set up, this could have easily been done with a traditional for loop. Now that I'm looking at it, usually the advantage of do until loops is that it might say do until x is more than a certain value or less than a certain value, that kind of thing. Right now, we're not really taking full advantage of its capabilities. But you're still at least seeing how it works. But here my result is equal to itself plus 2 times x equals itself plus. See, now at this point, though, this is where you have to be very careful. X now equals 5 and it stops. That's one of the quirky things about this. You might think it's going to go on one more time, but it's not. Once we come out of that last loop, once we execute this, once x equals 5, it will not go on and do another one. So the final result here is 20. So I personally think the for loop is the one you should use unless it's really necessary because it can get terribly confusing. All right, what other fun things to have here? Do while. Um, so do until means keep going until something is true. This one basically says keep going as long as something is true instead of until something is true. In other words, as long as something continues to be true, we keep going. Was the do until keep going until we reach a certain condition. So do you really need both of them? Probably not. Anything you could do with one, I'm sure you could do with the other. So keep in mind, though, this is where they're different. A do until of x until x equals n, like we just saw, we actually stop when x equals 5. To do the equivalent with do while means you have x less than n, because this one would continue another loop when it reaches x equals 5. So that's kind of a big deal. You have to know which one it is. So in fact, it looks like I went ahead and did exactly that. And so here we do while at x less than n. X equals n. That way, if I ran both of these programs with n equals 5, I'll still get a 20 as my result. Okay. Select case. This is what I started to tell you about before. And this is something that might be a better choice if you're using, let's say, grades, because you've got 5 possible grades. And all those if else's can get incredibly messy. So, oh, this is what I came up with. Suppose you have speeding tickets, and these are the fines or the different amounts of speeding that you've done. 1 to 5 miles over is 25, 6 to 10 is 50, 11 plus is 100. So there's only 3 of them. It still could get confusing with an if else statement. So here, if you notice, start with function find, speed is an integer. The result of this function will be, the find will be an integer as well. And if you notice, we have select case speed, that's the variable that's being passed into the program. And there's 3 cases, 1 to 5, 6 to 10, um, more than 11, 11 or more, sorry, greater than or equal to 11. And that's exactly how you would type it. And so the find is here, and then there's no other possibilities. So you have this end select, wraps up this loop, and then you end the function. Okay. So you can see how this could be very helpful, like with those grades. You can come back here and change it so that it's a case, okay, instead of a bunch of else ifs, because that can get, like I said, terribly, terribly confusing. And you can also have conditions here, like you could say grade is between 60 and 70. Anything you could do with the other loops, you can put here. This condition um, can be very complicated if you want it to be. Go to, now, go to is like, oh my God. It's like you might as well get into your Model T when you're running using go to. I mean, really. It means somewhere in the code you have a label somewhere. In this case, it's called error. So let's just say for some reason you've got a bunch of data. You're not sure if each part of your data is valid. Let's say you bought a bunch of data from some vendor, and you discover that there's a few of them in there that have bizarre characters that you weren't expecting. What you can do is, in order to avoid interrupting the whole thing, you can say, listen, if you run across a variable that has the following properties, then just go directly to the statement error and say, sorry, that's invalid. I can't do anything with it. So like here, if we want odd even, num is integer, it produces a string, which means it's got to be in quotes. If the number is 0 or less, then we call that an error. And it comes back with invalid to the calling function. Now, mod 2 means when you divide by 2, you get no remainder here. If num mod 2 equals 0, so that means it's the same thing as saying if I divide by 2 and I get no remainder, then of course it's an even number. Otherwise, it must be an odd. There's only 3 possibilities. Okay, so exit function, and then this comes down, or this has to be By the way, and you don't see that, we haven't seen this before, exit function. Exit function means out of the function, except for the possibility of a label down here, which is here, and then end function, which is what we're used to seeing. All right. So we've already seen dim. Static means static means if you want to use this in the future, let's say you want to run the program more than once, and you've created some variable that you want to save, like the sales tax rate. You want every time you run this program, you want it to be available to you. We can call it static instead of dim. So in other words, it's not, the information doesn't just disappear, it is retained in VBA so that you can use it again next time. Private, this gets into cases where you've got a bunch of different programs in the same spreadsheet and you may not necessarily want everyone to access all of them. And then also, this refers to naming conflicts. If you've got a bunch of programs in your same spreadsheet, the potential you could run into issues with the naming of the variables, which in principle, you could potentially accidentally use the same variable in more than one way. So what you can do is, set it up as private to make sure that it doesn't conflict with the others. Like here, for example, private tax rate is single, compute sales tax purchase is single, sales tax is single. Then we print these out on the spreadsheet. We print out the sales tax as the product, end of sub. So, it was converting static into private means it's now available to all the procedures. Static means it's not. Okay, so I don't think you're going to run into any of this. So, all right, so this is good. We've done all these. Now, what I'm going to do here is show you some code here that have opened up. Now, this program is designed to calculate Black-Scholes prices. And except it's being done in VBA instead of Excel. So what we want to do is see how it's different. So we're going to come back up here to data, not data, developer, Visual Basic. Now this is one of the awkward things that all the other stuff that was open is now still open. So I'm going to close off this one. And that way this one should only be the only one that's open. Oh my God, it's really, why did it do that? So if you want to run some of these programs, you can. These are the ones that we were seeing in the slides. Oh, hold on. It's just, here it is. This is what I'm after. I don't know why the others are still open. Now, it's a little bit surprising how simple. The only thing you got to watch out for here is that, like I said the other day, there are some functions that are in both VBA and Excel. And when that happens, you are required to use the VBA version. If there is no such variable or function available in VBA, to use the Excel version, you have to, wow, there's so many of these. All right, we're almost there. All right, now you'll probably be surprised by how straightforward this is. Let's see. Now, unfortunately, there doesn't seem to be a way to make this any larger. I'm not aware of one. So I'll tell you what I'm going to do. Let's copy this into a Word document so we can make it bigger. All right, so it's a function because you're only going to produce one number. That's the Black-Scholes price of call in this case. And if you notice, it's going to need a lot of information. The stock price, the strike price. Let's say it's a stock option. Stock, strike price, R is the risk-free rate of interest. Q is the dividend yield if there is one from Merton's model. If not, you just put a zero there. T for time to maturity, which is measured in years, and the volatility is the sigma that we used in Excel. And here, now this one you can't see because the colors are missing, but this is a comment. Hold on. It's so much stuff open in here. Yeah, see the green means it's a comment. It starts with an apostrophe. Now, these are the variables I'm going to use internally to the program. Disk R, disk Q, ND1, ND2. Now you recognize ND1 and ND2, but these two are just basically ways of making the code a little bit more readable. DISCR is e to the minus RT power. DISCQ is e to the minus QT. So if you go back to the slides on Black-Scholes, you remember, hold on, let me go get it. I'll just remind you or refresh your memory about what the Black-Scholes formula looks like. So the original Black-Scholes model does not have allow for any cash flows to the asset that we're pricing. So e to the minus RT is this piece here. Once we allow for that, the possibility in the more advanced version of this, which is derived by Robert Merton, the way we represent the cash flow to the asset is with the Q. So there it is. So e to the minus QT is here. Okay, it'll just make things a little cleaner. And then, of course, we know what ND1 and ND2 are. Now, D1, now, by the way, this is the interesting part. D1 is a separate formula. The way this function is set up, now look at this. I've got three functions in the same program. I've got the Black-Scholes function. I've got D1, a separate function for D1, and a separate function for D2, and they can all exist together side by side. VBA has no problem with this. And so when I need D1, which as you recall is actually that's D1 with a Q. If there's a possibility of having a Q in there, this is the formula we'll use for D1. And if you look at it carefully, you'll see that it's log. Now, by the way, this is one of those quirky cases. I mentioned this the other day. LOG in VBA means natural log. LN is natural log in Excel, but since it exists in both places, we must use the VBA version. Log S over K, R minus Q, et cetera, et cetera. So that's the formula for D1. And down here for D2, we have the same thing. It's just D1 minus the volatility times the square root of T. So because these functions are here, I can call them any time I want. And in fact, ND1, if you remember, is the probability. Let's just go back and revisit this. Once we know D1, the standard normal curve, then that's a probability. And the Excel command for that is the one we have to use. It does not exist in VBA. And so it's called norm S dist. Oh, sorry, that's wrong. It's this one. Now, if you notice, we're kind of doing two things at once here. And by the way, in order to use an Excel command, you must use this application keyword first. Now here, if you notice, I'm saying, well, listen, norm dist is applied to D1, but we don't know what D1 is yet. We have to calculate it right here with the D1 function. So you have to tell it not only that you're using D1, but how to calculate it. So that means here you're actually calling the D1 function and passing the results to application.normsdist. So kind of killing two birds with one stone. You're calculating D1 here from this function. And once you have that number, it goes into the normsdist function in VBA, Excel rather, and comes up with the appropriate probability. Same thing true with D and T2. And now you recognize this formula. It's easier to read it, I guess. This CQ, remember, is e to the minus QT. Where is it? Hold on. There it is, S e to the minus QT. So, where is it? Oh, yes. You know what? I'll tell you. Let me just copy it. It'll be so much easier. Instead of going back and forth and back and forth. All right, I'll put it right here so you can see it. So that's not part of the code. I don't want anyone to get confused. I put it there for reference purposes. So I'll make a little note here. So you can see how they line up with each other. Okay, and then and that's it. Believe it or not, that's the whole Black-Scholes formula. Wow. Because of the way it's set up, it's very straightforward. Now, what about protocol parity? Well, we have another program here that can do that. Let's go back to the slides. By the way, once that's in place, you can see that what you're actually doing here is saying, well, this is what you have to do to call that function. And remember, it needs to know SK, KR, QT, and Paul. It's a little awkward, but those are already sitting here. So what we normally do is use cell references rather than constants. That way, if I change something, it automatically updates itself. Like if I change this to 53, you'll see the results right away. And that's kind of nice. This one down here is a separate example, by the way. So then the Pocal Perry condition, we have a program here that which is designed to take the information from the call and turn it into a put. The code is here. There, this is hiding back here. I'll copy this as well so you can see it better. Okay, let's do this. Oh, this is actually not the Pocal parity condition. This is the alternative formula, which is down here. In other words, this formula, if you don't need the call price if you do it this way. Yeah, now one other thing I wanted to mention here is that this is a constant pain, but when you see X and K, half the option pricing textbooks in the world use K for the strike price, and half of them use X. And sometimes you'll see them both. I just noticed it now. The slides are calling it X. Here being used as K. It means the same thing. Those are the two standard ways of expressing the strike price of an option. So it's K here, it's X in the slides. It's the same thing. Now, of course, if you don't want to do it this way, but you can see why it would be very nice to have its own separate formula here because otherwise you have to, if you're going to put call parity, you're going to have to call on another program to come up with the call price. And that could get a little awkward. So instead, it's easier to have a formula where we can solve it directly, but you get the same results if you use call parity anyway. So so that's what this is all about. So with all these two programs, you can literally price any European option in the market you want. Think about that. Okay. So that's that. Now, what we need to do now, we still have some topics to cover, but what I'm going to do is write a very simple, straightforward assignment for you to do with the VPA because we do have to have a grade. And the course officially, I believe, ends on the last date is, I believe, the 15th. That means I can have that whole weekend to get your grades out, which means I can give you that whole weekend. And let's look at the calendar. So I'll have it ready by tomorrow morning. It'll be something very straightforward, very down to earth, because we haven't had that much time with the VBA. So I can have it due by, let's say, next Sunday night, the 17th. That way you'll have the rest of the weekend and the weekend. Sorry, Sunday the 18th. Oh, wait, no wonder I was confused. This is 2024. No, it's a week from tonight. So, all right. So I'll send out an announcement tomorrow. I'll actually post the assignment itself. It'll be one or two things you have to do based on what we were going over, and just to show you that you've got some basic understanding of option pricing theory and the VBA language, and then we can carry on and do more exciting topics. And these are kind of for your own benefit. I'd like you to see how the um, American pricing model works. And I'd really like you to see the Monte Carlo simulation because it's extremely interesting. And really, it enables us to do all kinds of other kinds of options where so far we've only considered American and European style options, but there are some others that are much, much more complicated, known as exotic options. And it turns out that in many cases, simulation is a better way to price them than with these traditional methods like Black-Scholes. So that's because their properties are very complicated. So we'll get through all of that. And then by this time next week, we'll have all the material done. You'll have your assignment, which, like I said, won't be too time consuming, but something just to show that you get what we're doing. And then we'll be done with the course. Now, there is another half to this course available if the school offers it, but we'll discuss that at another time. So anyway, so I guess we'll stop it right here and I'll see you in the next session.